This is the explanation video for problem set 12, week 12. Problem number 1 is asking us to use a power series representation to approximate this integral that we are given. And it's being evaluated at 1/2 and 0, and the integral is dx divided by 1 plus x to the 6th power. So what I decided to do was, first of all, to kind of finagle with the overall equation and left that to 1 minus negative x to the 6th, so that way I could put that into a summation series that made more sense to me, which was negative x to the 6th to the k power, or negative 1n x to the 6th n power. And then we found the integral of this series, and from that we are able to get negative 1 to the k power, x to the 6th n plus 1 divided by 6n plus 1. And I found that our approximation was negative 0.5 minus 0.5 to the 7th over 7, as we plug in x, or 0.5, 1/2, to this integral, and we get about 0.50116071 as our approximation. And as we find that out, it's that overall integral equals 0.49889321. So pretty close. Question 2 is asking us for a survey measuring the difference in elevation and taking into account the curvature of the Earth for a certain highway across a desert. And it gives us C equals R secant of L divided by R minus R. So I just wrote out the fourth derivatives to find the fourth degree. I did not do those all by hand. I plugged those into a calculator just to kind of help me do those more quickly. But at P4 of x, we get 1 over 1 factorial x plus 1/2 factorial x squared plus 2/3 factorial x cubed plus 5/4 factorial x to the 4th. And if we plug in all those secants and tangents, that is what we get for each of those numbers up there. So as in 1 is our 1 over 1 factorial is the overall number for our first derivative there, secant divided by LR, tangent divided by LR equals 1, and so on. So evaluating this at our radius being 6,370 kilometers, which is the total radius, and we're using the highway that is 100 kilometers long. So we are dividing 100 by 6,370, plugging that into our overall equation that we found for the fourth degree, and we get about 0.0158235 kilometers have to be corrected for the curvature of the Earth. Moving on to the third problem. We are supposed to find the radius and interval of convergence of this series here, which was 2 to the k times x minus 3 to the k divided by k. So first I applied the ratio test to this. So r equals the limit as k approaches infinity of 2k plus 1 times x minus 3 to the k plus 1 divided by k plus 1, and all of that divided by 2k to the k times x minus 3 to the k divided by k, absolute value of all of that. And just simplifying here, we get to take both absolute value x minus 3 out of the equation, and we are left with just evaluating the limit of k over k plus 1, which is just 1. And we are left with 2 x minus 3 absolute value has to be less than 1, so we put our r being 1/2. And we then evaluate this 2x minus 6 from negative 1 and 1, and finding our interval, we just solve for x on each side, so that would be 5/2 on the low side and 7/2 on the big side, and that is our interval, 5/2 and 7/2, r being 1/2, I being 5/2 and 7/2. Alright, thank you.